Okay, hi, morning. Before we get started, hopefully you noticed that homework 2 has been assigned, and it is due 3 weeks later. It is because next week we don't have a class, right? Next week, according to our NCKU schedule, it's the so-called it's a day off for intercollegial communication, interaction, something like that. Okay, so anyways, no class next week, and I think then the due date for homework 2 should be 3 weeks from now. Okay, and I believe you know homework 1 is due today. And by the way, at first, I think I told you guys our midterm exam will be during the first week of May, but I think I may postpone the exam a little bit later. So maybe around the second or the third week of May. Okay, around that time. Is it okay? Because I think, mainly it is because the intercollegiate sports games have been postponed. Okay, and that is why I think we can reschedule everything a little bit. 反正就是期中考我本来预计是5月第1个礼拜，但是因为我是要配合大专运动会，那现在都延期，所以我想期中考也不用那么赶着，一定要在5月初，所以期中考应该会在5月中，反正就是在5月。OK， yeah. Okay, so let's see. Maybe we should quickly review what we have learned so far. Okay, so what we have learned are basically the so-called classical methods. Classical. Okay, so we have learned classical optimization methods. And basically there are two categories. One, without constraints, okay, and then with constraints. Right, so we have learned the two things. And without constraint, we know that we can use the necessary conditions, okay? So we can use the necessary conditions to find some candidate points, and some of them may be the minimum points, and some of them may be the maximum points, and some of them are neither. Okay, so the necessary conditions in 1D is like df dt, df dx equals 0, or in ND we have the gradient vector being a 0 vector. Okay, so it's for a one-dimensional problem. If we have only one variable, this is what we need for the necessary condition. But if we have n variables, then using the gradient vector, taking partial. Do I need to write down everything? Okay, maybe. So if we have n variables, taking the partial derivative with respect to all the n variables, and each one of them is 0. Okay. Yep. So this is the necessary conditions for an unconstrained case. And we also have the sufficient conditions. Or maybe I should say with constraint later. Okay. So the sufficient conditions are that. So the sufficient conditions. I mean, let's say for minimization, okay. And for maximization, it's very similar. I think you can just check the class notes or check the books. Okay. So, anyways, for the sufficient conditions, we have second order derivative being equal to 0. Being greater than 0. But actually, if the second order derivative is still 0, then you need to check the higher order derivatives, okay? Okay. Right. You may need to check higher order derivatives if this second order derivative dx equals 0, okay? Yeah, in this case you may need to check higher order derivatives, and do you remember that depending on the order, okay, if n is an odd number, then basically it's still similar to this. But if n is if n is an even number, then we have a very similar situation like this. But if n is an odd number, then it's we can we know that the point we have found is neither a minimum nor a maximum. Okay, so I need to repeat a little bit. 反正这个还记得吗？看更高阶的微分，如果到了譬如说第4阶才会发现是不等于0的时候，这时候你就要看在第4阶的时候它到底是大于0还是小于0。那如果是到第3阶才发现它的这个微分不等于0的时候，那 n 等于3是奇数，这时候你其实你得到的既不是 maximum 也不是 minimum。Okay, yeah. Anyways, I think you can check the class notes. Yep. For minimization, the sufficient conditions for MD is like the Hessian matrix. Okay. Yeah, the Hessian matrix is positive definite. Positive definite. Okay. Yep. So H is the Hessian matrix. Hopefully you remember what this is. Okay, yeah. I think after doing homework 1, you know what I'm talking about. Okay. So that's the unconstrained case. Okay. And how about with constraints? Okay, so with constraints, then either equality constraints, right? Or inequality constraints. Okay, and for the equality constraints, I think we have learned 2 methods, right? Either using substitution or using the Lagrange multiplier. Okay, and for inequality constraints, we have learned the transformation method, right? So, transforming into equality constraints Okay, or using the KKT conditions. Okay, or using duality theorem. Duality and saddle point theorem. Okay, I think let's just say duality theorem. Okay. But the thing is, all of these. Oh, and by the way, the duality theorem can also be applied for solving equality constraint problems. But I think that's fine. Okay, so let's just have those here. But what I want to say is this: all these are for the necessary conditions. And then you may want to ask, what do we do if we want to make sure whether the point we have found is a minimum or maximum or neither? Yeah. So I think I should say it over here. Yeah. So all these. Yeah. Okay. Yeah, still it's not. The pain is not as good. Maybe I can try this one. Okay. So all these are still are still necessary conditions. And so my question is, then how do we know the points we have found are the minimum or maximum or neither? You know, there's a mathematical way. I think I wrote it down on the class notes, right? Okay. That is using some vector, some kind of vector in the feasible direction, and then performing this the dot product, okay, something like that, and then if it's greater than 0, then what we have found is a local minimum or local maximum, something like that. However, doing that kind of computation might be very tedious. Okay, so usually in practice we do not do that. 我再说一次啊，就是在 class note 你可以看一下，我这边就不写了，就是它其实有一个比较严谨的数学的式子，就是当你用完这些 necessary condition 之后，找到一些点，然后再去用比较严谨的那个数学式子来说明它的确是 minimum 或者 maximum. Okay, but that kind of method will be very tedious. Okay, so in practice, we just perform function evaluation at nearby points. Okay, and of course those nearby points should still satisfy the constraints. Okay, nearby points which still satisfy the constraints. Satisfy the constraints to show what we found is a minimum or maximum, okay, something like that. Okay, so this is usually what we do, and I know this is not a very strict way, but it's a lot easier, okay, and usually this is fine. Okay, but and if you want, you can perform this kind of function evaluation at more points around the points you have found, and then you will be more confident about whether you have found is a minimum or a maximum. Is it okay? Yeah. Again, because if you want to have that kind of very strict, very mathematical definition for the sufficient conditions when you have constraints, then the computation effort is a lot. Okay, so that's why usually we can just do this. Okay, yeah. 可以吗？就是当你找到一些点之后，就是当有可能性的时候，这些其实都是 necessary condition。那找到那些点之后，你要怎么样知道到底你找到的是不是 minimum 还是 maximum， 或者都不是？你就在附近的几个点，当然也是要满足 constraint 的附近几个点，然后去看它的 f function 值。如果附近的点都比你找到的点的 function 值大的话，那当然你刚刚找到的应该就是 minimum。OK。So this is a very easy way, for you to identify whether it's a minimum or a maximum. Okay. Yep. I think basically that's it for the classical methods. Okay. Yep. And then today we can move on to talk about the numerical methods. But any question before we continue? Okay. Yep. I think it's always better to have a quick review before we get started. Yep. Because the thing is,